If you get to know how printf works and if you like it, there is also another possibility to use a string widget, for instance. And you can what you can do is you can use string static method named format. And format inside the string uses the same arguments as printf. So basically we can take this as parameters for this format right here, and we'll use yet another output statement. We'll just use a print. I can simply use print line this time and print the result of this string that I'm constructing. And those two should be exactly the same. So if I run this, you see that I get two identical outputs, but the second time, before printing this, I am capturing this formatted string inside a brand new string object, which is constructed from the ideas of formatted specifier as a first argument, and then a list of parameters that gets embedded and converted to appropriate data types. So just something to remember with printf, because sometimes it's possible to, instead of just printing specific output, it can be quite useful to capture it inside the string and retain it for later use. So since we're started talking about conversions from one type to another, we may have to use helper classes integer, float, and double to convert numeric strings into internal data types or primitive data types. So these classes are called also wrapper classes for the corresponding primitive types. So I'd like to note that basically when we were talking about invoking this constructor that had a parameter such as this integer, so we said that primitive data types, when we're constructing this widget and passing 123 as an integer right here, we said that integers such as this are passed by copying. But it's possible to basically create primitive data types using these wrapper classes. For instance, we can say integer equals new integer and pass some kind of integer as a constructor to this initializer. And my NetBeans environment prompts me that this is quite unnecessary to do. Alt Enter would show us some hints what to do, so I press Alt plus Enter. Right, so if I on top of this, if I press Alt plus Enter, it's a very useful function in our editor. So when you're seeing this, you press Alt Enter and it shows us some tips. So it tells us that new integer can be removed because this will be the same as doing something like this quite directly. So this time, if we go back to creation of our widget, and we'll try it one more time. So this time I will pass the integer to this code, and we'll print it one more time. Okay, so just like this, we will print it. It's not going to be anything spectacular. It's just going to print the different code, and I'll call it gadget so that it stays recognizable. and I'll just run it again. You can see that we've got the gadget printed right here with code 456. Okay, but the important thing is that I just wanted to show you why these classes are called wrapper classes. So basically, in the first example, right at the top, when we use this integer, and if we use just an integer to allocate it like this, int code equals 123, and we pass the code as the parameter to our widget or constructor, then in this picture what we get is a variable which is a local variable right here in our main method. But if for some reason I don't want to allocate integer as a local integer, I can revert to something like this. And so integer, this data type in Java library, is a library class that we refer to as a wrapper class. So this time it becomes a reference to an object which internally stores this value 456, and the copy of 456 is allocated dynamically. And here we just get the reference to dynamically allocated integer by Java Virtual Machine. But you can see right here that you can use this in every place where the code is expecting an integer parameter. So what is going to happen here is that we're still gonna pass the copy of 156, but it will be extracted out of this dynamically allocated object. And here we're still going to get our integer with the value 456. And again, this is a copy. We can change it and so forth. But it's just an interesting feature here. It becomes very useful in a library design to have these kinds of wrapper classes. But this is as close as possible that you can get to allocating an integer dynamically as opposed to allocating it as a local variable. Just to let you know that this is how Java works, and so this is why we call them wrapper classes. And these types of helper classes exist for all basic data types, all fundamental data types. So in addition to this type of functionality that we just discussed, we have parse methods, which are static methods, which will take string as a parameter and convert them to the corresponding data type. So this is an example of integer parse int, float parse float, and then double parse double. So here you can observe that we have a string that contains a fractional number. This is negative fractional number. It contains this fraction here, and the call to double parse double, the result of this parsing will result in returning an actual internal double data type. So these are these types of conversions are easy to use when you have a string data and you expecting a certain format in that string, and you're trying to convert it to the native data type. So you can choose your specific wrapper class, helper class in the library, whether it's an integer or double or boolean, and pass the string with what you are expecting to convert to the native internal data type, and you can use the specific parse method with that.